is the solution that if you plugged in any number from there, x squared plus 4x plus 3 would be less than or equal to 0. Now, to give you an option of checking your work, we're going to take a look at the graph, or the graphing calculator for this, and let's take a look. And in fact, let's bring up a new sketch. Did I already sketch this one? Nope. And let's graph this one up. Go ahead and take out your calculator. We want to graph the function x squared plus 4x plus 3. And again, we want that to be greater than, or excuse me, I said that wrong. We want that to be less than or equal to 0. And just to verify it, it seems like it's hit 0, negative 3, negative 1. That's good. That's the points we found. And it's negative or below 0 in between. So that graphically verifies our solution. Stop and check up questions on that. All right, let's take a look at another example. So this is using that test number method to find that interval of solution. So let's look at one that's very similar, but we're going to run into a little crux here. So we have x squared minus 2x less than negative 2. Now, first question to you. It'd be a lot nicer if this was less than or equal to, or less than what number? Okay, 0. How can you do that? Just by adding 2 to both sides. Now, just because it's inequality, you don't have to go crazy. There's still those algebraic properties you can use to make your life easier. In fact, let's use that for this one. X squared minus 2x, add 2 to both sides, plus 2 less than 0. Now, let's take a look, try to factor. So what numbers multiply to 2, add a negative 2? Give you a second to work on that. Hopefully you're saying to yourself, none. Okay, when that doesn't work, what do you got to do? Well, you got 2 options left. You can either complete the square, or you can use the quadratic formula. I'm going to use the quadratic formula for this one. So we have negative b, so negative 2, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, when your teacher was talking about the discriminant, you probably, oh, why do I have to learn that? I'll just plug it all into that magical thing I got in my calculator, that program. The discriminant can save you a lot of time. And let's look at that. The discriminant is what's under the square root. Because if it ends up being negative, we run into some issues. So let's just look at the discriminant, and I'll pull that off to the side here. Negative 2 squared gives us 4. Minus 4 times 1 is 4, times 2 is 8. 4 minus 8, negative. What does that tell us? That tells us there's no real solution to this. So in other words, there's no number you could plug in and get 0 out that's a real number for this particular problem. What does that mean for us? Oh, that means we're in trouble with this. We don't have any test numbers or any key points we could use for this. So we have to just plug in a number, see what happens. So for this one, we're just gonna do a little guess and check. We're gonna plug in a number. Pick an easy one. Okay, let's go for 0. 0 squared is 0. Minus 2 times 0 is 0. Plus 2 is 2 less than 0. No. Let's take a look at the graph of this one. See what this one will give us out. So let me delete this guy out. Let's graph a new one, and we had x squared minus 2x plus 2. Looking at the graph, what does the graph tell us about the solution to the original problem? Now, key thing, do we want it less than 0, greater than 0? We want it less than 0. What does the graph tell us about the solution where that happens? Yeah, if here's the line 0, here's the line 0 in here, here's the line 0. Let's click off that. Here's our line. Does it ever go below that? Nope, never goes below that. So is there any solution to this? Nope. X squared minus 2x has no solution. then what does that mean? That means there's no number you could plug in that would make x squared minus 2x less than negative 2. Now, what does that say to the reverse of that? What about x squared minus 2x greater than negative 2? If this one has no solution, there's no number that makes it true, this one, by both looking at the graph and by actually just deduction, we can say that this one has all real numbers. In other words, for any number you plug in, x squared minus 2x is greater than negative 2. Interesting. Interesting, fun problem we run into with these. Let's stop, check up questions on that. All right, let's take a look at one more example, one more type of thing we're going to run into tonight. This one, again, different type, but this we run into those same rules we had with multiplication, but this time we run into it with division. Even though we haven't been introduced to this term, this is called a rational expression or rational function. They're fairly well behaved for something that involves division, but for this one we're going to use it with those key numbers, those test points again. We have x minus 2 over 3x minus 1. And we want that to be less than or equal to now 0. As you're writing this problem down, let's talk about how that equal sign has a part of our solution. How would that change our solution? What if that equal sign wasn't there? Well, when we get to the final solution, let's talk about that, or let's look at that. So how do we find some key points here? I said in the first part that we look for where it would equal 0. And for this to equal 0, does the numerator or the denominator have to equal 0? Well, if the numerator equals 0, the denominator doesn't equal 0, the whole thing's equal to 0. So we'll look at where x minus 2 equals 0. What about 3x minus 1? If that was equal to 0, that would make this undefined. That's probably a point we're going to be interested in. Even though we haven't taken a real in-depth look at that, we will later in chapter 4. Let's take a look at where 3x minus 1 is equal to 0. Because that will cause us some issues, or probably not be a part of our final solution. So x minus 2 equals 0 means that key point is that x equals 2. Two-stepper, so we'll have to solve this one out. So our two key points we're interested at are x equals 2 and x equals 1/3. Now, just to give you the visual sense for this, you might be able to identify the intervals right off, but just to give us a number line sense, here's 0. Our first point is at 1/3. Our second point is at 2. So where are our intervals? Our first one we'll have to check from negative infinity to 3. In fact, let me just get my table started there. Our first interval is from negative infinity to 1/3. Let me make that negative a little bit darker there. The point 1/3. Then from 1/3 to 2. The point 2. Then from 2 to infinity. Now, the book does not include these 2 points, but I include them just so we have that conversation about are they a part of the final solution. This one really brings up that point because one of these gives us no solution, one of them gives us an answer of 2. That just needs to be a part of our conversation when we're finding those intervals for the final solution. A lot of times what students do is they'll say, okay, it's equal to, so it's a bracket. It's equal to, so it's a bracket, when then you will end up having a bracket at a point that's undefined. So let's find a key point or a test point to try out in those intervals, and let's pick an easy one here. 0. 0 is always easy. For this one, let's pick an easy one, 1. And for this one, let's pick an easy one, 3. And again, we'll test it in x minus 2. We'll test it in 3x minus 1. And we'll see what x minus 2 over 3x minus 1 is. Is it a positive? Is it a negative? Now, let's just review really quick. If we have a positive on top and a negative on bottom, a positive divided by a negative is a negative. If we have a negative on top, negative on bottom, negative divided by a negative is a negative. Okay. Same rules for multiplication, even though this one does involve division. Positive and positive is a positive. One of them's positive, one of them's negative. It's negative, 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 positive. So let's try it out. 0. 0 minus 2 is a negative. 3 times 0 is 0. 0 minus 1 is a negative. So negative divided by a negative gives us a positive. Is that part of our solution? Let's go back to the original problem. X minus 2 over 3x minus 1. If it's positive, is that less than or equal to 0? Nope. We plugged in 1/3. That made our denominator 0, so this point was undefined. What that really tells us is that this isn't a part of our solution set because it won't be less than or equal to 0. Plug in 1. 1 minus 2 is negative. 3 times 1 is 3. 3 minus 1 is positive. Negative divided by a positive is a negative, which for us ends up again being a good thing because that's part of our solution set. Plug in 2. 2 gives us 0, which is good because that's part of our solution set. 2 to infinity, plug in 3. 3 minus 2 is a positive. 3 times 3 is 9, minus 1 is 8. That's a positive. Positive, so that is not part of our solution set. So let's again have that conversation. What does our solution set look like? At negative, at 1/3, that's undefined. That can't be part of our solution. But from 1/3 to 2, that is. Now really quick, you're thinking, okay, parenthesis at the start, parenthesis at the end, but does 2 solve our original inequality? You plugged in 2, you got 0, which is okay. That is a part of our solution set. So that is part of it. 2 works. 2 gives us 0 out for an answer. So kind of weird. A problem that originally started with an equal sign ends up with a parenthesis down at the bottom. What solution set solves this from 1/3 to 2? Which example that kind of runs into everything you're going to run into your homework tonight. Kind of a tough one, but ends up having a solution that's kind of awkward. Let's take a look at the solution set for that, really just to show what the graph looks like as we are trying to use the graph to help us find the solution. So let's plot. We had x minus 2, 2 divided by 3x minus 1. And we wanted to look at where that is less than or equal to 0. So definitely down here, this is our point where we are interested in that solution. Definitely, it's easier to see that it ends here at 2. So that's definitely one boundary of our solution. Where is the other one? We have to look at, okay, this keeps going down for infinity, infinity. Where does it end at? That's why we have to have that algebraic process. It's somewhere here between 0 and 1. Where is it exactly? We found it to be at 1/3 using that, but that will verify our solution. Where is it less than or equal to 0? From 1/3 up to 2. All right, and that is what we cover in section 4.7. That's section 2.6. We're in 2.6 today. Sorry about that. Section 2.6, that pretty much ends what we're going to talk about. That is the end of chapter 2, end of inequalities. As we look to review for the end of this chapter, make sure you cover everything we started with. Lots in this chapter, especially section 2.3. Lots in that section on solving equations. A lot of info in that. Again, thanks, and if you're here on campus, we'll give you your homework assignment.